Hello everyone, so we went through a pretty straightforward example of a countdown using a recursion method, but now we're going to look at some more advanced examples. One of them is printing vertically, which is the scenario where if we have an input of a non-negative integer n, we want to output the integer n with its digits stacked vertically. So essentially if we put in 1, 2, 3, 4, we should get 1, 2, 3, 4 put backwards for us. Now, essentially, before we even start looking at how we could code this, we got to think about the base case. And this is a very good thing to do whenever you're going for recursion is how are you going to end your problem? So essentially, what do you need to build towards to end this recursive call? And in this scenario, why don't we just think about the scenario where we have one thing to print, right? So if we just have one item to print, and let's go ahead and pull up our recursive practice again. If we have one item to print, and let's just call this function vertical. In the file, there's a file called py.vertical.py that calls it as well. But let's just go ahead and look at our base case. If I want to vertically print out a single digit, then we can just go ahead and say print n. But how do I tell if it's a single digit or not? Well, if it's from 0 up to 10, and we're going to say a non-negative 0, so we could say if n is less than 10, then we can go ahead and print 10. And again, this will work for us pretty straightforwardly. Let me go ahead and comment out these guys here. It's a bit redundant, but of course, if I put in a 9, I technically printed out the one value of 9 vertically and 8 so forward. So cool. So that's the easy part. We have the base case, but how do we go ahead and we find the recursive solution to it? Now, there's a few ways that we can do this. We can go ahead and try to see how we can access the last digit. Excuse me. Down here it says we could print all but the last digit by making a recursive call, and then we could print the last digit. Now, there's a few questions here. Why the last digit and not the first one? And not print the last digit before the recursive call? And we'll look at vertical pi after we code this up together for a bit more information on that. But let's go ahead and try to mimic what this functionality is saying. We could print all but the last digit. So how do I actually go ahead and print all but the last digit? Well, if I have the value, let's say n is equal to 361, how do I access the last digit? Well, I could try doing a full division by 10 here, and you'll notice here that when I do an n divided by a whole division by 10, I actually truncate that last digit that's right there. Now, this is interesting because, again, if I'm trying to print the numbers vertically, I need to put the tree and then the 6 and then the 1. So if I do something with like, hey, set a is equal to n divided by 2 and then print a, I'm going to go ahead and see that I'm getting rid of this last one. Now, what we would need to do here, after we go ahead and we try using this n divided by 10 here, why don't we also try using this modulus operator by 10 as well? So if my n is equal to 361 still, and I do my n mod by 10, you'll see here that when I do a division by 10, I get all the numbers except the last one, and if I mod it by 10, I get the last number. Now let's go ahead and see if this works for all values. Let me do an n mod 10 here. And it looks like I'm getting everything except the last one. And let me do an n mod 10, and I'm getting the last one. So essentially, inside of Python, inside of these code as well, we have these tools that are allowed to us that we can use inside of our function that will go ahead and kind of show us how we can grab the last digit and then the remainder of the ones as well. Now, we might be wondering here, how do I go ahead and actually implement this into my code? Well, for the time being, why don't we try to go ahead and put an else statement that we can work towards, and let's just simply go ahead and print n mod 10. Now, if I can go ahead and try running this, let's go ahead and do my vertical of 361. We'll see here I'm getting the last digit. So I'm not really getting what I really would like to get just yet. I'm only getting the last digit. And you'll see here the logic that we're trying to go for is our n is equal to 361. When I go ahead and I mod it by 10, I get 36. And if I technically put this to 36 now, and I type out n and I mod it by 10 again, you'll notice that now I actually have the first digit. So what we could do in our inductive step here to be able to reach this n is less than 10 is to gradually, or excuse me, recursively reduce our n by a whole division of 10. And what I mean by recursively reduce it, I mean that instead of doing an n minus 1, like we did above in the countdown function, what we can do is an n mod by 10. Now, what will happen here is that we are going to recursively call this vertical n mod by 10. And let's go ahead and actually, excuse me, let's go ahead and comment this out for the time being. And now let's try to do a vertical of 361. You'll notice now that I actually was able to recursively go back, keep reducing my n each time until I got to the end there. And to really show off what's happening here, I can take a print of an n. And what I'll do, this looks a bit confusing right now. Let me go ahead and say another line here inside the if, like so. And you know what I'm going to do? I'm going to do a vertical of a bunch of numbers here. And now we can see that I recursively cut off the last digit of my code until I hit my 1. And then once I'm in my 1, it gets printed out right here. But now I go ahead and go inside the if, and then it says if, inside the if, print an n. So what we can do now is, why don't we try adding in this print statement of n mod 10. And again, when we did an n mod 10, we saw that it gave us a bit of a output there. So I'm going to do a vertical of 361. And now we can see, because I printed out this n twice, it seems like we're not getting the exact thing that we'd like. But now we see that I get tree inside of my if statements, and funnily enough, in my else, I still have this n mod 10 being printed, and then my 1 being printed as well. And you might be wondering, how come this print statement is running, and why are these guys printing after it? Because what should be happening, right, is that if I go ahead and hit, if I type in n is equal to 361, we could do this in Paint really quick. So if my vertical of 361 is ready, let's just go ahead and say that this is line 1, line 2, line 3, line 4, and then line 5. What happens here is that in V361, I skip line 1, I skip line 2, and then I hit my else, I enter into my else, and I go to line 4. So my first thing that this does is go to line 4, and I run line 4, and what does line 4 do? Well, it truncates the first one. So line 4 puts V36 inside of my item there. So this function call, again, doesn't disappear. There's an activation record that it's in the notes, it is referred to as an activation record. But essentially, your function of V of 361 and V of 36 are kept over here on this activation record. And now, because these guys are kept on the activation record, they are going to be, it's kind of like a stack of pancakes, you can imagine it as. Because they're kept on the activation records, these still have to run at some point. They're just not running right now. So on our console, they're not running out. But we're at V36, and what does V36 do? Well, does V36 hit into line 1? No, it doesn't. V36 also goes to line number 4 over here. And what does V36 do at line number 4? Well, it truncates that last one. So now I have a V of 3. So luckily I have my V of 3 over here as well. And this guy gets placed on the activation record next. And now what happens in my activation record? Well, in V of 3, I actually hit my line number 1. That is true technically, so I print out my N. So I print out 3. And what gets displayed to my console, and let's just say my console is down here, I print out my tree. Now that's great, that solves V of 3, but again, what I said earlier is, hey, wait a minute, you still have these guys on your activation record. So what's going to happen here? Well, we are actually going to go jump back to line number 4 again of our code, and we're going to go 1 below it to line number 5. Because this is essentially, this piece of code is still on the stack and it's still waiting to run. It just hasn't ran yet. So now what we need to do is after we go ahead and we hit this code, well, what does end of mod 10 do for us? Well, let's try to type it in. What is 36 mod 10? It's 6. So what do we print out now? Well, now we print out 6. Now this one is done and it's off the activation record. And this guy is done after this one. So now I go back up to line number 4 again, and I could jump down to line number 5. Sorry, my drawing gets a bit messy. But now we can see I have V of tree 61 over here. And what is tree 61 mod 10? Oh, it's a 1. And so what needs to happen is this print statement still runs for all of these items on this activation record. And so that means that the tree 61 gets modded by a 10, and then so does the 36, and then that actually mimics the behavior of us printing out these items vertically. And you could see here, tree gets printed out first, and then the activation of 36 mod 10 gets printed, and then the activation record of 361 mod 10 gets printed. And again, this is something where the practice of recursion comes into play, because some of us might think that after we go ahead and we do these calls that we're done after we hit the if statement, but there is still code underneath this piece of code up here that needs to run, that runs after the base case is done. And that is where recursion gets the most tricky, is because there's code that you might not think will run that needs to still run after the activations are there. And this activation record is from the notes right here, is where we store the values that we are seeing at n in activation records. And if you actually go into your vertical.py file, you'll see here that if you uncomment these print statements, this vertical.py file, let's go ahead and say vertical of tree 61. You'll see here that we enter vertical of tree 61. And we format n. And then do we hit this if statement? Nope. We go ahead and we go down to this vertical call right here at line number 7. And then we go back up to this entering vertical at 36 because we divided it by 10. And then what happens again? Do we go to this print statement? Nope. Because we entered this vertical call, we jump back up to the top up here. Then we enter into this print statement again, entering vertical of tree. And now what happens? Well, we don't go down here. We actually hit this if statement. We print out n. And now we're leaving vertical of tree. And now we'll notice I'm actually going to put leaving vertical in the else. Let's go ahead and see if this will do anything more for us. We'll see now that we still have these values in the activation record of the else after these verticals, where we still have the remainder of n there. And you'll notice that the n value is actually changing. N used to be a tree, and now it's at 36, and now it's at tree 61. So we're actually getting the values back to what they used to be. So again, this is a more complex example of vertical. And again, please make sure you take a look at the vertical printing as well. If you can get behind the idea of you are still running the code after your base case, you will be set with recursion, because that is mostly the toughest part to get your head around. After you go ahead and get through that, you'll be good to go. Awesome. So there's plenty more examples inside of this advanced recursion as well. They're inside of week 5. If you take a look at the recursive examples py file, there's one for summing, there's one for vertical and counting up, and there should also be one, I believe it's under exercises, that talks about lists as well. We'll talk more about lists later on, but please take some time to look through these. Recursion is very tough to get your head wrapped around, but once you do it, it's easy sailing for more of the tougher examples in the class. Excellent, everyone. Great work this week.